Now the next radical equation we're going to look at together is the square root of 3x plus 7 being equal to x plus 1. And this equation differs from the others we've looked at in that we have two terms on the side of the equation that does not contain the radical. So I think you can see what we need to do to eliminate the radical would be to raise each side of the equation to the second power. And the left-hand side will simplify to 3x plus 7. Now you want to be very careful here on the right-hand side. You recall from your earlier work that when you square a binomial, you should get a trinomial. And if you're pretty comfortable doing these in your head, we would end up then with x squared plus 2x plus 1. The most common mistake here will be for people to simply square the x and square the 1, and they will forget the middle term of 2x. Now if you're not comfortable doing that squaring mentally, what I would encourage you to do then is to go off to the side and write down the x plus 1 twice and use the FOIL method to carry out the multiplication. And if you do that, you would have an x squared plus x plus 1, which would simplify then to the x squared plus 2x plus 1. It's better to do this and be safe than take a chance that the squaring that you carried out is not accurate. So now we have a quadratic equation, and we need to make one side 0. I'm going to choose to make the left side 0 because I want to keep the x squared where it is with a positive coefficient. So we then have x squared, if we take the 3x and the 7 to the other side, x squared minus x minus 6 is equal to 0. We next factor, and we'll factor into x minus 3 times x plus 2. And so the possible solutions would be 3 or negative 2. Now you know we need to check each of those to see if they're valid. So let's first check the 3. So we'll go back to the original equation and replace x with 3. So we have then the square root of 3 times 3 plus 7. Will that be equal to then 3 plus 1? So we'll have the square root then of 9 plus 7, which becomes the square root of 16. And the square root of 16 is 4, and that is equal to 4. So the solution x equals 3 does check. Now we'll next look at the solution, the possible solution, x equals negative 2. And replacing x with negative 2 back in the original equation. We have this. And inside the radical, that will simplify to negative 6 plus 7. The right-hand side simplifies to negative 1. Then we have the square root of 1. And the square root of 1 is 1, which is not equal to negative 1. So the only valid solution then to this equation is 3. So we'll end up by stating that formally. So the solution, since I'm running a bit out of room, I'll place it up here. So the solution to the equation is x equals positive 3. Now, let's come back down here to where we checked the negative 2 for just a moment. And I want to point out something that might be helpful in the future. Now let's zero in on this step right here for just a moment. Now regardless of what the left-hand side here simplified to inside, it would be impossible for the left side to be equal to the right side, because when you have a square root with nothing in front, it's asking for the principal or positive root of that square root. And so there's no way a positive number or zero number could be equal to negative 1. So we could have determined really at this step that the negative 2 was not going to work. But sometimes we don't see that initially, and if you want to work it all the way through to be absolutely certain, that's fine also.